Insights, solutions, and networking all come together at RSA Conference. Join a global cybersecurity community at rsaconference.com/ITSP-MAG24. SquareX helps organizations detect, mitigate, and threat hunt web attacks happening against their users in real time. With its innovative browser-native security product, SquareX safeguards enterprise users from a spectrum of web-based threats, encompassing malicious files, websites, scripts, and compromised networks. Learn more at sqrx.com.
And hello, everybody. This is Sean Martin. I'm flying solo on our Chats on the Road to RSA Conference. Marco normally joins me, but he's off recording another episode. So we're splitting duties here today. And I'm kind of glad because he's not going to interrupt me as I'm talking to two cool people, Allan and Bob from CISA. They're both speaking at RSA Conference, two different sessions, and we're going to explore the topics of those and the intertwining of the topics of how we secure by design and keep it secure and know when it's time maybe to retire some stuff that we can't secure, right? It's a big picture there. So I'm excited to have this mashup of topics and thrilled to have you on. I'm going to pass the mic to each of you to kind of share a few things about what you've been up to, what prompted this topic to be submitted, which, by the way, congratulations on getting accepted. It's not an easy feat getting accepted as a speaker at the conference. So I'll go alphabetical. Allan, what have you been up to?
Sure. Thanks, Sean. I really appreciate the chance to chat with you. We're looking forward to RSA this year, and as you pointed out, it has gotten a lot more competitive in the past couple of years. Most of you, if you've heard of me, know me as the guy who doesn't shut up about SBOM, or software bill of materials. And over the last couple of years, that work has been taking place at CISA. And just as a quick reminder, CISA, or the Cybersecurity and Infrastructure Security Agency, is America's cybersecurity agency. Not only do we work to secure the federal civilian government, but we work to defend the American infrastructure today and build out a more secure future. Now, one of the challenges as we look forward to the future is understanding that not all software is going to be able to make that journey with us. Sad but true. And end of life and end of support software, I think, is a little bit like software supply chain and software dependencies, which is everyone knows that it's there and everyone knows that it's a problem. In fact, it's such a background problem that we haven't really done much about it. And so the talk I'm going to give is really going to try to sort of launch a broad scale, both technical and policy level approach to try to wrap our hands around it. And that's what I'm excited to present in a few short weeks.
I love it. And I only picture you in an SBOM shirt, even though I've never seen you until today in an SBOM shirt, but that's how I picture you, Allan.
You know, once you have a brand, you got to live it.
I know. You embrace it and then run with it. And I have so many thoughts on the end of life. Not just purely for the end of life, but for the broader picture of security posture. So I'm excited for this chat. And Bob, it's been a while. Good to see you again. What have you been up to?
Well, let's see. So I think, just kind of taking the starting point of the RSA talk and kind of unwinding that a little bit. I think a lot of what I'm doing here at CISA is trying to learn from the scar tissue I developed earlier in my career, helping build products for both consumers and for enterprises, and then transitioning to be a defender, which is, I think, where when I was, running security programs at places like Twitter and then at Yahoo, and then most recently at the Democratic National Committee after the 2016 hacks. And that's where I became really intimately familiar with the levels of safety in the software products that we all buy and use, both as consumers and as enterprises. So DNC is sort of a classic small, medium-sized business. When I joined, there were about 200 people there. And it was really me and some help desk folks and some sysadmins trying to keep the Russians out again. And that's when it dawned on me that this was inherently an unfair fight, because the tools that we had were not really going to protect us. And so I had the great privilege of joining CISA a couple of years ago to start our Secure by Design program, and really take advantage of some of those rough times in some of those previous jobs to try to help influence how software gets made, not just nationally, but really everywhere. So that's really been the focus of what I've been doing. And then almost exactly a year ago, we released the first iteration of our Secure by Design white paper. And then we've had all sorts of iterations of that and other papers, RFIs, memory safety papers. I mean, you name it, we've really been trying to drive the conversation. So this talk at RSA is really just yet another iteration of us trying to give examples of Secure by Design and get people to really start to focus on what can be done.
I want to jump to the session, but first I want to talk about this idea. We were supposed to secure by design, so we didn't. So now we have stuff running that shouldn't be. How is it? What's the chicken or the egg? Do we ditch the old stuff that doesn't work? Do we fix it? Do we just start over? I don't know. What's the answer?
I think when you're trying to build a security strategy and then policies to implement that strategy, and also then ultimately implement it at companies with finite budgets and organizations with finite budgets, we always want to look forward to be making the future stuff better. And we know that the existing stuff is never going to go right. There's no easy solution, but what we can do is be a little more rigorous about how we talk about the old stuff. And so I think they almost necessarily have to go hand in hand.
Yeah. This is evolution. So like it's evolutionary. So we're unlikely just to start throwing everything out and starting from scratch. That would also not work. In addition to not being viable, you'd have you'd start using things like memory safe programming languages, but then you'd have a whole bunch of new logic bugs that you don't have today. And so, I think the thing that people have been doing, so it's not just our opinion, it's what actual practitioners who've had success in this have been doing, is working to replace portions of systems in very thoughtful ways, to Allan's point, and really trying to analyze from the security perspective, what is it that the adversaries are going to go after? What is it that would be useful for them to take control of? And then to start figuring out ways to deny them that access. And there are all sorts of ways to do that. The good news, bad news is there's a lot of really low-hanging fruit. Most of the vulnerabilities that we see on a regular basis are not head slappers. They are not brilliant innovations that come from left field. I'm sad to report that they are the same classes of vulnerability year after year, decade after decade. I mean, there's a paper from 2007 that MITRE wrote called Unforgivable Vulnerabilities. And in it, they lay out this list of criteria, like what would cause us to feel like a particular class of vulnerability is unforgivable. Like it's just terrible that somebody would have this class of vulnerability. If you hold up that list against the 2023 MITRE analysis of the top recurring vulnerabilities over the previous 5 years, would it surprise you or anybody in the audience to learn that they're mostly the same? That it's directory traversal, it's memory safety, it's SQL injection, the list goes on. And so the good news is there's lots of ways in which organizations can simply become more aware of these facts and start thinking about classes of vulnerability and start chipping away at the problem. And those who have had some pretty good successes. I mean, there are some, like when was the last time you saw a cross-site scripting vulnerability from any of the major online services? It just doesn't happen that often. It's incredibly rare. I can't remember the last time. I'm sure somebody's going to do a search right now and pull one up that That is the evidence that proves
There's
the
always
rule.
an exception, Bob.
Always an exception that proves the rule. But like in the world of networking gear, it actually is not uncommon. And so there are segments that have found ways to eliminate certain classes of vulnerabilities and others that haven't. And so I think a lot of what we want to do is have people share that information so they can begin those first steps of that 1,000 miles.
And then I'm going to pull this back here. One of the challenges and one of the high priorities, why do we care about whether or not something's old? And one is just, hey, I've got a lot more gray in my beard than I used to, and things don't work quite as well as they used to, right? Everyone reaches this, every generation discovers getting old for the first time. But there's also one of the priorities is what happens when the supplier of the software is no longer in a position to say, oh, that vulnerability that probably shouldn't have been in there in the first place is something we can no longer fix. And that is really sort of the foundation of why end of life and end of support is a key security issue, is making sure that organizations are in a position to understand what their exposure is. Just because it's old doesn't mean it's bad. But what we do need to do is be prepared for these flaws, because there will be vulnerabilities that are found in end of life and end of support software. And we're going to need to know what to do about it and have a plan.
Yeah. And that goes up against the idea that some things are battle hardened. And the question is, are they battle hardened for the battles that we're facing today and in the future? And that's always a harder question to answer.
Yeah, and I think for me, the challenge comes with visibility, especially in your world, Allan, of course, all these things. What is the age of my extended family? Well, who are they? Where do they live? I don't know all the stuff that's part of my software supply chain and my bill of materials, let alone how old they are, if they have vulnerabilities that exist for ages and ages. So I know you're doing a lot of work there. And you mentioned policy frameworks in your abstract. So I don't know, are you going to lean into some of that in your session?
We definitely are. So first, again, how big and how bad is the problem? Well, I'll pull two examples. One was a piece in the Wall Street Journal that characterized end of support software is a $1.2 trillion problem. Rip and replace is simply not a scalable solution, right? And by the way, your friends in the US government are probably the biggest user of software that is out of support, right? We kept Windows 98 in service well after what Microsoft wanted its end of date by, because we said, hey, listen, we simply can't wean ourselves off it fast enough. The other piece in terms of, what's the scariness from recent headlines is Ivanti was yet another wake-up call in a spring full of wake-up calls of, oh my God, our software supply chain is terrible. And one of the things that people looked at when they looked at the brand new, I just paid for it, Ivanti endpoint product that was connected to the internet, it had 8-year-old components, 10-year-old components, 15-year-old components in there. Whether or not there were known vulnerabilities in these components, the idea that we're building our infrastructure on top of things that are that old has to be a warning sign. And I've spent the last 6 years of my life saying we need transparency in the software supply chain and making the case for why, and then trying to operationalize the how. And so we're going to try to apply some of those lessons learned of what was really hard and what were the important pieces of it to having visibility into the age of things in our software world, starting with the top level products, but also explicitly incorporating this into the supply chain level. And of course, that means open source.
Yeah, because I mean, so you mentioned government agencies using Windows 95. When I was slinging software and delivering stuff to defense agencies, the rules you have to, and basically you sign off on stuff that ends up living for years and years and years, right? To change it is like moving mountains. So you have we can't because it's not easy. We can't because policy says we can't. And if you think, like I'm thinking like to Bo Woods and Josh Corman, you start looking at the medical space and a lot of regulations around safety. Some of those things you can't easily change either. So those are specific cases of where you can't. But then the majority, we could easily say you should still have to. But why do they get the brunt if all these other areas say we can't?
And so one of the core things that we've learned from the rise of SBOM is the value of separating definitions, machine readable labels and tooling and metadata, and then policy on top of that. And if you try to build everything together, you're simply not going to scale. And so, the T's of what we're going to be talking about is definitions. Right now, there are like 20 different terms for different types of end of service and end of support and end of life. Let's try to have one core one that we can then map to what sectors are already using. 2, think about metadata, right? How do we make machine readable labels and build an infrastructure where people can provide that data, share that data, consume that data? And then the last piece is having policy informed by data. And what that's going to look like is going to depend on organization, capacity, risk, sector, et cetera. There isn't going to be a one size fits all. But what we can do is create a world where it's reasonable to expect an organization to happen. And sort of I stole a line from supply chain expert Dan Lawrence, who paraphrases famous Marine General Mattis, which is, be kind, be polite, and have a plan to update every piece of software you use. You don't have to do it, but you need to have visibility of everything that you might have to update and have a plan of what you're going to do when something comes along that makes that a higher priority.
And Bob, so that plan might be to upgrade, replace, rewrite, refactor, something to help mitigate some of the challenges. And I think you're going to take things even deeper and looking at memory safe code. So tell us a little bit about what you're going to be sharing.
Yeah, so I can tell you a little bit about my origin story here. So I consider myself reasonably plugged into a variety of things, and I'll confess that in 2020, I was helping shepherd a couple of conference talks at the Enigma conference, and they were about memory safety. And this was just a random coincidence, and so I had the great honor of working with Alex Gaynor and Chris Palmer to help them rehearse a number of different times to get their timing down and make sure it had the right impact. And I think it was maybe on the second time I had heard them. We had 3 different sessions. The second time, I believed them. I think the first time I literally didn't believe them, and I had to go back and do a bunch of research and look at their citations, because what they were telling the audience, it just seemed like an exaggeration. It just seemed like if this problem were as big as they said, there should be just a monumental wave of energy from the software industry to go fix this. And I saw no such sign. And on the second rehearsal, during the briefing afterwards, I said, guys, I don't know that you have enough punch here. Like what you're saying, these statistics need to have emotional punch. and I just got punched, and I just felt like this was a huge blind spot for my. And so we did the third time, and they delivered great talks. They're out on the internet, and I just couldn't get this out of my head. Like, if we really do see the largest companies who are doing thoughtful analysis of their code, determining that 70% of their vulnerabilities are tied to memory safety issues, this just seemed like there should be a call to action. And what's interesting is I talk to other people who's, I tell them that I was shocked by all of this, and they say, I'm shocked that you're shocked, Bob. Everyone knows. And I was like, well, define everyone, because I think what you have is a small priesthood of people who have been doing amazing work in a certain bubble. And those of us who are just outside the bubble, we just didn't see inside for whatever reason. And so when I got to CISA, one of the things I wanted to do is not just push secure by design, but I wanted to raise awareness, both that people have been really working hard on this for decades, and they've come up with literally dozens of different mitigations, which have raised the cost to the attackers, to be sure. The work has not been in vain, but that we still see just a tremendous number of vulnerabilities that are tied back to memory safety. And so we need to take some action.
Can you share an example, Bob, of maybe a well-known or a common scenario where memory safety has been an issue, and maybe a mitigation that the groups put together?
Yeah, so don't want to give away anything on the second half of the talk, but in terms, it's like when you watch a movie trailer, it's like, I'm pretty sure that was the end of the movie. Like, why did they do that? You shouldn't show anything.
Don't do that. But
don't give us the second half of the movie. I just saw the whole thing. I saw the hero say the one-liner, and then everything blew up, and America and the world is saved. Great. So I think in terms of the setup, it's not just that these problems exist and that it's 2/3 of the vulnerabilities you see from various manufacturers who are, of course, primarily using C and C++ for a lot of their products. We actually see real world harm in the form of things like the Google's Project Zero, taking a look at in the wild 0 days that are fired, and again, 2/3 of those turn out to be related to memory safety. So it's almost like no matter which way you look at the data, you get a very high number, often around 2/3. And so there are real world harms caused by this. And odds are when you see certain kinds, like when I see the news, I don't know, Alan, if you do the same thing, or maybe Sean, you do the same thing, like you see a particular vulnerability and you're like, oh, that's in the SMS system. That's a memory safety problem. Like there's just no way that they rewrote the whole subsystem in the last few years. Like that's a lot of work. And then it turns out almost always to be correct. So there's some real world harms here. And if you take a look at a lot of the edge networking systems that are getting compromised, memory safety is implicated in some of those as well. So it's something that we really just need to take a look at and start working towards. And one of the things that we called for in our memory safety white paper was a roadmap. So you're talking a little about like, how do you know what your upgrade cycle is? Well, we want to know when you're buying a product, we know that you can't rewrite everything in a memory safe programming language anytime soon. You should have a plan. I want to see the plan. And could you please post the plan? The plan might be a 15-year plan. And you might say, I wish it was 5, but like, I'll take 15 if you're actually making reasonable progress towards your goal. And so, like Alan said, like have a serious plan is going to be key. But we really want that to be public. We really want software companies to explain to their customers what it is that they're doing, how long they think it's going to take, how they're training the developers to migrate the code, how they're measuring success, all that good stuff.
Yeah, transparency, good. I'm sensing a theme here. Have a plan.
Absolutely, you have to have the right plan. I mean, and so we're seeing things like upgrading and making sure that you have the right products in your deployment from a defender side, but from the software developer side, we want you to have a plan to make sure that you're not falling victim to the classic vulnerabilities. Memory safety is really just the one at the top, but it's obviously not. It's not the only one. Again, with the edge routers, command injection SQL injection. These things have been around for literally decades. Mitigations have been known for decades. So, whichever way you look at it, having a plan that really talks about making real progress, not just activity, is critical. And customers deserve that, and you should be explaining that to them. Along with all the other feature improvements and integration points and all the other great stuff that a company is doing, we want to see how you're making sure that you're building something that's going to get safer every time you do an upgrade.
Yeah. Well, businesses care about resiliency, right? And I think this speaks directly to that. Yes, you want to be concerned about the end customer as well, but those aren't there if the business doesn't exist. If something goes haywire. So I have a dream for cybersecurity that we as security professionals have a view of this world like nobody else, and we have data at our fingertips like nobody else to help guide the business to say, we need to not just buy another control to mitigate the risk. We need to help define how we build our business. And to me, that goes to what is you mentioned the logic earlier, Bob. That to me, that goes to what is the end to end? How does this stuff flow? How does the data flow? How do the systems connect? How does the network support that? Who's then down to the supply chain and bill of materials? Who has all these pieces, parts that make all this work? And I guarantee in there's a bunch of stuff that's making security teams pull their hair out, patching all the time, not able to patch, configuring firewalls to compensate for not being able to patch, whatever it is. And if we could just say, we have this knowledge, if we change this stack in this way, we help our team, we build a better workflow, we reduce logic issues perhaps, and we can overcome some of this end of life junk that we're dealing with, and perhaps replace it with some secure by design stuff that's memory safe. But that's my dream in a nutshell. Do you think we're getting close to something like that?
Allan, you want to go first?
I mean, whenever we look at a data-filled world, there are two things we need to acknowledge. One, scalable, machine-readable data across the ecosystem is really one of the only things that we have in our favor as defenders to help scale, right? We need more automation. We're only going to get more automation with more data that is aimed towards automation. So that's one of the good news pieces. Who's going to be using this data is something we need to be very real about. One of the things we talk a lot about CISA here at CISA is the cyber have-nots, and we want to acknowledge that, right? Small and medium enterprises have a lot of things going on. Sean, you've already invoked my friend Josh Corman, who spends time using the Maslow's hierarchy of needs for security. I think we didn't sort of get that. So a lot of what we try to build here are things that, the super elite hyperscalers may not need the government's help. As we slowly move down that Fortune 500, they have resources, but security has to fight for resources. And so how can we help them sort of make it a little easier and cheaper to scale and get that first wave of tools out into the marketplace that can handle, well, I'll say SBOM, I'll say secure by design concepts, including memory safety. And of course, I'll talk about end of life, where we need to sort of build this into our existing tools. And then the hope is that down the road, for the ones that have scaled, this just becomes turnkey. It's something that gets integrated into every MSSP, something that gets integrated in every policy, into every compliance framework that, whether it's government or like PCI or something like that, and build it into that. So I think that's how we try to integrate this idea of transparency. Can't just be visibility in terms of surveys or manually filled out reports. It has to scale for automation, and that should be where we are aiming.
Yeah. Yeah, and I love that vision, and I do think that is absolutely attainable. I think that there's no reason why we can't. In 1965, Ralph Nader wrote a book called Unsafe at Any Speed, and it was about the built-in unsafety of American automobiles. And that book caused such a furor that the government had to act, and it created what we now know as the Department of Transportation and some of the other agencies that are responsible for automotive safety. And that really dramatically helped improve the safety of American cars. And I think looking back, I think part of Nader's vision and part of his genius was articulating the idea that car manufacturers couldn't make safer cars until we all believed that cars could be safer. And we're in that exact situation with software, where software makers can't make their software safer until we all truly believe in the idea that it can be made safe. And so a lot of what we're trying to do is raise awareness, have the conversation, and say, what is it that is causing some organizations to build products that are resilient against these common attacks and others that just keep playing whack-a-mole with these recurring classes of vulnerability. And so I do think that we can do that, and that's what we're working on.
I love it. I have faith in both of you and the bigger team surrounding you. And the first steps in having the conversation is your sessions. So
is given that talk at RSA.
That's right.
And the other thing I'll also say is both Bob and I do try to be a little more entertaining than your average government bureaucrat when we're.
It should be more fun. Yeah, it should be more fun. Yeah,
there'll be a little more memes, a little more jokes than
we all study your technique. We are all working to be as entertaining as you. I have not yet achieved that, but I do promise to be a little bit above average.
I'm looking forward to both sessions. So I'm gonna share those with everybody now. So smashing the stack, let's make it less fun and unprofitable. That's Monday, May 6th at 9:40. That's you, Bob, with Dan Wallach from DARPA.
He's amazing.
Yep. And all good things, end of life and end of support and policy and practice. That's Tuesday, May 7th, 1:15. And that's Allan flying solo on that one. You get the stage all to yourself there, my friend.
So good. So good.
That way no one can upstage me.
There you go. Well, gentlemen, this has been really fun. It's good to see both of you again. Congratulations on the session. It's important. These conversations need to be had. And I hope the rooms are filled, and then you have a lot of people coming up to the stage after and meeting you and learning more. And I think what I heard earlier is the plan, and I think taking action on that. So engaging with you and the rest of the CISA team is important. So
we can do hard things.
Yes.
Thanks, Sean. Looking forward to seeing you in San Francisco.
Right on. Safe journey. And everybody listening, watching, thanks for joining me on this Chats on the Road to RSA Conference. Loads of stuff coming still. Please stay tuned. itsbmagazine.com/RSAC. See you all in San Francisco.
SquareX helps organizations detect, mitigate, and threat hunt web attacks happening against their users in real time. With its innovative browser-native security product, SquareX safeguards enterprise users from a spectrum of web-based threats, encompassing malicious files, websites, scripts, and compromised networks. Learn more at sqrx.com. Insights, solutions, and networking all come together at RSA Conference. Join a global cybersecurity community at rsaconference.com/ITSP Mag 24.